Hi everyone, welcome to talk session. Here question is to design NFA to accept all the strings which starts with A. What's the condition here? Condition says that string should start with A. So based on this condition we can write down minimum length string. Here first MLS is A because it's starting with A. Once string starts with A, after this A another A may come or B may come, because string is starting with A, or it may happen that if string starts with A, multiple A's may come, or one string starts with A, multiple B's can come, or combination of A and B can come. It doesn't matter because string is starting with A. So based on this, start designing automata. Q0 is starting state. First string is A, which is the minimum length string. For this we are going to design automata. This A should get accepted. It means what? By reading A, automata should go to the final state. So hence I am making Q1 as a final state. As I mentioned in last video, once we design automata for our main condition, then let's make it deterministic or non-deterministic. Here in the question they have mentioned we need to design non-deterministic automata. It means what? That I have explained in one of the video. The link is given above. What does non-deterministic property says? If suppose sigma consists of A comma B, then there may be zero or many transition from one state for A as well as for B. So it is not mandatory to have transition for A from each state, or there may be more than one transition for A from one state. Similarly, there may not be transition from another state, for example here Q1 for symbol B, or there may be more than one transition for symbol B. So there may be zero or many transitions for each symbol in the case of non-deterministic property. Now let's make this automata non-deterministic. What's the condition here? String should start with A. So string is starting with A. What happens starting with B? It's not allowed, but as it's a non-deterministic, no need to write down transition for B here from the Q0. So as I mentioned you, string should start with A. After string started with A, automata is reaching to state Q1. So automata is at the state Q1. After this A, multiple A can come, maybe single A, double A or triple A. One string is starting with A. Or there may not be any A's. So single A is only there like this. So what is that Q1? Nothing means epsilon. So Q1 is looking for zero number of transition or for A, or 1A or 2A or 3A. What is this? Zero or many. I have explained this in last all videos. So zero or many means what? Self loop. At which state? Q1. For which symbol? A. So at Q1 I can give the self loop for A. What's the conceptual meaning? One string is starting with A. After that many A's can come. 3 A's, 1 A or 2 A or no A's. That's the reason I am giving here self loop. Similarly I can design for the B. Because one string starts with A, there may be more than one B like this. So string is started with A. After this one B can come, or two B's can come, or 3 or many more B's can come, or no B's are coming means epsilon. So Q1 is looking for zero number of B, 1 or 100. That's what? Zero or many. So Q1 looking for zero or many B's. If zero or many B's means what? Self loop. And this becomes our final NFA. Here you may think why there is no transition for B from the Q0. Because we have to design NFA, non-deterministic. As I explained here, non-deterministic property says that there may or may not be transition for each symbol of the sigma, or there may be more than one transition for a symbol of sigma from one state. This becomes your final NFA. You can practice similar kind of example where you need to design string starting with 1 over the sigma 0, 1. We need to design only NFA. In the next session we will be designing NFA where string is starting with AB. Thank you for watching.